Hey everyone, welcome to our technical training session regarding OPC data aggregation and tunneling using the Cogent Data Hub. We'll be covering what aggregation and tunneling are, why you use them, and how they're accomplished in today's session. My name is Catherine Winchester, and I, along with Win Worrell, will be your host for today's presentation. I'll go ahead and pass it back to Win really fast. We just want to do a quick survey so we get an idea of how familiar everyone is with today's topic.
Sure. Okay. I have a quick poll that I'd like to do. We're going to take a minute and a half here to do it. Really, it's just two quick questions that see how familiar you are with aggregation and tunneling. The first poll talks about data sources and what type of data you want to get your data from. A data hub can connect to a variety of different data sources. So we're just curious at what type of data sources the audience has. The second question, for those of you who've gotten that far, is do you use tunneling? Some people may already use it, some people may not. We've got about 45 more seconds here for everyone to answer. This will help us get a good feel of, looks like most people are talking to OPC data sources. Wow, in the close second is embedded devices. That's very interesting. And third, ODBC. Huh. It's surprising to see embedded that high up there. That's great information. I appreciate that, guys. Awesome. Giving you guys another couple seconds to submit your responses here, and then I'll hand it back over to Catherine, who can go ahead and start with the presentation. It's 5 more seconds, Catherine. I'll let you know when it's done. Okay. Go ahead, Catherine. You're up.
All right. Well, today's presentation is going to take about 45 minutes. Let's start with a quick overview of the Cogent Data Hub, the tool that we're going to be talking about today to teach you the what, why, and how of aggregation and tunneling. After a short overview of what the Cogent Data Hub can do, I'll explain what aggregation is and why we use it to bring data into a single interface for your OPC clients. Once the data is aggregated, we'll talk about what data tunneling is and why it's a great tool for bringing data through a firewall or across networks without DCOM. After, Win will show you how easy it is to set up and use aggregation and tunneling. We'll cover some additional use cases for these powerful tools. Win and I would be happy to answer any questions you may have following the presentation. So, Cogent Data Hub. What is it? Cogent Data Hub is a single software package with a variety of features. We break the functions into 3 different categories: connect, integrate, and use. The Data Hub can connect to a variety of data sources, such as OPC data sources, including both DA and A&E. We can act as both a client and a server and connect with DDE, ODBC, custom.NET applications, Linux, and other non-Windows operating systems. And we can also connect to Windows system information, such as memory usage, CPU usage, or what processes are running. Once you have the data in the Data Hub, you can integrate that data. The Data Hub also provides different methods to use the data that has been gathered. Some examples are logging it to a database, sending out email alerts, or visualizing the data in a web page. The Data Hub includes all the functions listed here. Today we'll just be focusing on 2 of these, aggregation and tunneling, using OPC DA and Linux connections. We will start today's training by discussing OPC aggregation. OPC aggregation is the bringing together of data from different OPC servers into a single data source, so that one or more OPC clients can access this data through a single common interface. While we'll be demonstrating aggregating data from OPC data access servers, the Data Hub can also aggregate data from other sources like ODBC and DDE connections. So you can bring in data from databases and Excel spreadsheets and provide the same information to OPC clients. With the Linux interface, Data Hub APIs and scripting can also bring almost any data into the Data Hub. Of course, you can also send the Data Hub information to any of these same sources, so you can log the data to your ODBC source and read the information in Linux or other custom applications. So why would you use aggregation? One of the advantages of aggregation is that it can be used to ensure a common and consistent update rate is passed to the OPC server and thus to the hardware devices. You may not realize this, but most OPC servers decide what rate to pull the hardware devices based on the requested update rate from the OPC client. If you have capacity limitations in your control network and want to ensure a random OPC client doesn't come in and overload it with an unreasonable update rate, then OPC aggregation is a way to accomplish some regulation of traffic on your control network. Aggregation also allows you to get OPC data to multiple OPC clients when the OPC server only allows a single OPC client connection for technical or commercial licensing reasons. Similarly, some OPC clients are licensed based on the number of servers they can connect to, and the cost can become enormous if you have multiple OPC servers you need to get data from. Aggregation helps solve this problem as well. Aggregation also helps with OPC servers that create additional connections to the PLC for each client connection or don't optimize requests well by ensuring that only the data hub's requests are making direct connections to the PLCs, DCS, or other control hardware. At the end of the day, using OPC aggregation can help you reduce network traffic, improve system performance, and save you time and money in the implementation of your systems. Now that we've covered basic aggregation, let's talk about the tunneling feature. An OPC tunnel passes information between an OPC client and server, across the networks or the internet without using DCOM. Not all OPC tunnels do this in the same way. The data hub does this by using a TCP IP connection on a single port number that doesn't use any of Windows COM or DCOM functions. The whole DCOM nightmare goes away because you simply have to ensure that the chosen TCP IP port number can pass between the PCs and through your routers and firewalls. In the example shown here, we are using the OPC data hub to move data between a remote OPC client and server, which we'll be doing live shortly. This connection between the data hubs can also be made secure through a number of techniques. It's important to understand that in this type of tunnel, OPC data hub tunnels the data, not the OPC remote function or procedure calls, so it does not suffer from the blocking behavior of OPC calls. So what are blocking calls? In a software developer terms, a blocking call is when one program asks another program to do something, and the requesting program sits and waits on the remote program to respond, thus blocking all activity on the requesting application, including the user interface interaction, until that call completes. All OPC function calls are, by their nature, blocking calls. The client or server will wait on the other to respond to a call. This applies whether you're doing reads, writes, or subscriptions with your OPC-based system. Normally, it's not a problem if you're locally connected to your OPC server and all is well. However, you've seen the downside of this if you've ever used DCOM and had your client HMI appear to freeze or lock up while trying to get data from a remote PC. That freeze happens because your client has made a call to the remote server and is waiting on a response. It would be one thing if the requesting application, you could just give up at a reasonable time, but it's not really possible, even though I know every OPC developer out there wishes they could just have their client give up. Our friends at Microsoft put a hard-coded 6-minute timeout into DCOM. That, folks, is what causes the apparent application freezes you see when you try to use DCOM and the connection's not working because of security or permission settings or the server's just not running. So eventually, we get to try again after our 6-minute timeout. But the data hub gets around all of this by tunneling data, not function calls. It's a big difference. The tunnel is optimized and designed to move data, and all communication is done asynchronously with non-blocking calls, so it can run significantly faster, actually up to 50 times faster in some cases, than an OPC tunnel that just passes OPC function calls up and down a TCP IP pipe. This also means that losing the connection between the tunnel data hubs won't cause your OPC client to hang while waiting for a response, because your OPC client is just talking to the local data hub's data store, which is constantly refreshed with data from the remote server when the connection goes up. When the connection goes down, it'll automatically resume when the network connection is restored, and while it's down, you'll know in an orderly fashion. Wynn will give you the whole how of that in a few moments. The data hub acts as more than just a conduit for data, though. It also acts as a mirror of the data from remote OPC servers back to your local client machine. That means a single tunnel can support any number of clients on each side of the tunnel, and the data flows across the tunnel only once, yet as you can see, serves multiple clients. This can greatly reduce bandwidth usage across slow networks. So the biggest reason to use OPC tunneling are obvious: to get around the limitations of DCOM and what can often be a nightmare to troubleshoot, to be able to move data between OPC servers and clients across the internet and through routers and firewalls. but there are many other reasons that might not be so obvious. The first is there to deal with network interruptions in a graceful manner. As we said earlier, there are many different approaches to tunneling. With some approaches, all that is really solved is the problem of removing decom and firewall from the picture. It's important that a tunnel to be able to handle network interruptions gracefully and recover too, which some tunneling implementations are able to do, as we'll show you today. Very slow networks are another reason to tunnel. Data can be moved a lot more efficiently when it's moved as data versus being wrapped up into remote procedure calls. If you're just tunneling OPC commands, you're tunneling wrapping of these commands and data, which will be less efficient than just tunneling the data. Connecting to non-OPC systems is another big reason, such as DDE, ODBC, and any other source the data hub can connect to, even non-Windows. Any device that can open a socket connection, send a text command, and parse the response can communicate with the data hub. Overall, people choose to tunnel because they need their systems to be reliable and as high as performance as possible for their specific application requirements while using a reasonable amount of network resources. So now that we've covered the what and why topics, we're going to start with a fun live demonstration. So I'll pass it back over to Wynn here in a second.
Thank you, Catherine. Appreciate that. And I will share my desktop here. Great. Looks like everyone can see my desktop. So first thing I'm going to do is start the data hub. The goal of the live demo is to show you how to both do aggregation first with the data hub and then how to do tunneling. So the first thing we're going to do is launch the data hub, which will put the icon here in my system tray. And if I open it up, we can see all the different functions the data hub supports. So the data hub can connect to OPC DA, A&E, DDE, database, system monitor information, as well as some other ways, other data sources when you're doing something like scripting. For example, we can connect to web pages and read web page data. But today we're going to focus on OPC and tunneling. So let's start by creating an OPC connection to my local OPC server. I'll call the connection top 1. This is on my local machine, and I will choose the top server here. Let's set a data domain name. Data domain is a fancy word for group in the data hub. It has nothing to do with Windows domains. It's really just a grouping construct in the data hub. Next, we need to specify our update rate. This is how fast the data hub will request data from the OPC server, and in turn, how fast the OPC server will request data from the device. So let's set this to 500 milliseconds. We can change the read and write method, and there's some other options that we could play with. We're not going to mess with those for this demo. You do have the option to manually select the tags from the OPC server, where you can browse the address space, choose your tags. In this case, we're just going to load all the items. Click OK. Now, the data hub does not connect to this OPC server until we click the Apply button. So when we click the Apply, we save the configuration, and we make a connection to that OPC server. You can see the status went to running. And if we view the data, we have our top server domain. And let's just look through here. Looks like we have some changing data. So that's one OPC connection. Let's add a second one. So let's close this. And we'll add a second connection, this time to our Omni server. So call this Omni1. Connect to the Omni server, and this data domain is going to be called Omni server. Again, we're going to use a 500 millisecond update rate, and we're going to load all the items. Click OK, Apply, and we're now connected to 2 OPC servers. So if we look at our Omni server, we can see we have data changing there as well. Now, this is aggregation can be useful because what you can do here is specify how the data hub will connect to the OPC servers and what update rate to pull those devices at, or those OPC servers. And then your client's pull rate doesn't affect how fast the data is being requested from the device, because your client would connect to the data hub, but in the data hub, you control the scan rate to the device. Okay. Now that we have two OPC connections, let's tunnel some data from a Linux box that is residing in Canada. So go to the tunnel mirror section. The data hub on the Linux box will be our master. So we need to add a master connection. The host name is developers.cogentrts.com. The port's 4502. The local data domain is where in this data hub are we going to put the data. We'll just call that test. And then the remote is also called test. You do have the option to specify a username and password. We will be using that later when we do another tunneling connection. And you can secure the data using SSL encryption. And that's recommended so that the data isn't going over just a regular unencrypted connection. We have some options about data flow direction. And the bottom here, as Catherine mentioned, there's a 6-minute DCOM timeout in Windows. Since the data hub has configurable timeout settings, we can configure the timeout to anything we like. So by default, we have a heartbeat of 1 second, a timeout of 5 seconds, and then we will retry that tunnel connection every 5 seconds as well. So this allows us to notice a connection is offline very quickly. That way we can connect very quickly as well. So you shouldn't be down for more than, let's call it 10 seconds here, right? So if we click OK, we click Apply, that connection went to running as well. And if we go to our test domain, you can see here that we're getting data over our tunnel from the Linux box over in Canada. And how the data hub tunnels data is every time a data point changes on the other side of the tunnel, that data point is sent over to this other data hub. So you can see these data points are changing rather fast. I'd say every 100 milliseconds here. The data hub tunnel has been tested with over 100,000 point changes per second. So we can support a high volume of data changing very fast. Okay. So now what we've done, we've aggregated data from 2 OPC sources and a tunneling source from a Linux machine. The last thing I want to show is, let's show how we tunnel to, say, an OPC server that's running on a Windows XP machine. So before I show the tunneling, I want to show, well, let's just try to make an OPC connection through DCOM. So I'll call this remote tops 1. This is on IP 192.168.111.87. And it will choose the top server. And we'll call this remote tops. We'll set an update rate of 500 milliseconds, and we will try to load all the items from the server. If we click OK and then Apply, you can see that we're trying to make a connection to that. Let's watch this. So it's a server lookup, pauses, tries to register for callbacks, and that fails. Let's open this up and view that in the connection viewer here. So if we open up here, the connection viewer shows you every connection that the data hub has. So you can see here, here's our local connections to our 2 OPC servers here, and here's our remote connection. You can see that this connection is flipping through some states, but it's mostly staying disconnected. And we've received no data, right? Whereas our other 2 local servers are continually receiving data. Okay, so what we can do here is, let's kill this. Before we do that, let's see what error we got. If we go to the event log, we can see we're getting an RPC server is unavailable. Well, what does that mean? We know that's DCOM. So we have 2 choices. We could try to configure DCOM and see if we could get that working. Maybe, maybe not. But we know that connections between Windows 7 and Windows XP can be troublesome sometimes. We've seen more problems with that when the operating systems are not alike. So what we can do instead is disable this OPC connection, and let's connect to this with a tunnel. So I've installed a data hub on my remote OPC server machine, and I have connected it to the OPC server on that machine. So it already has a connection to the OPC server locally. So what I'm going to do now is configure a tunnel connection to that remote data hub. So we'll use the same IP address. In this case, we're going to use secure tunneling using SSL encryption. The remote data domain is just called remote, and we'll put this into the data domain remote tops. Let's see, what did I call it? Remote tops 1, I believe. That's fine. And then, as I mentioned before, we can specify a username and password. I'm just going to use the admin username and password. This is recommended, especially if you're tunneling over the internet. That way you've secured your data hub, locked it down, and only users who have that username and password can access that data on that data hub. Okay, we're going to use the default settings for the timeout. Click OK, click Apply. Okay, you saw the connection come here into the connection viewer, and it is running, and you can see we have data changes. So if we click the View Data, here we see we have our data changing from our OPC server that is remote using the tunneling connection. If we go back and look at what we're seeing from the plain OPC server connection, we have a bad quality and no data, right? So let's see what happens when we disconnect the network. So let me just move this down here. Okay, so remember Catherine said that we have a timeout of 6 minutes in DCOM. Data Hub, we've configured a 5-second timeout. So let me reach over here. I have the computer right next to me. I'm going to unplug the network connection, and we should see that the data stops immediately. And if we wait the 5 seconds, the quality will change from good to a not connected status here. There we go. The tunnel is now disconnected, and you can see how we're going to be retrying every 5 seconds to reestablish that connection. And in the meantime, we have a not connected quality here for our data. So you can see how fast that timed out, and then if we plug it back in, you should see how fast we recover. So if I plug that right back in, probably wait about 5 seconds, and we've just reestablished our connection over the tunnel. Okay, that ends the live demo here. What I'll do is stop sharing, and I will pass the presenter ball back to Catherine, who will finish up the presentation with just a few application examples.
All right, so since Wynn just demonstrated how easy tunneling and aggregation can be, we'll go ahead and we'll talk about some different examples of how aggregation and tunneling can be used effectively to solve connectivity and integration challenges. So when multiple OPC clients connect to multiple OPC servers, an individual connection is made for each client to each server. As we can see in this example, 3 clients connecting to 3 different servers. Using aggregation can greatly reduce this traffic, as you see in this example. So I'll go back. Just without aggregation, you've just got data kind of going everywhere. But with aggregation, you've got efficient data flow. So tunneling can be helpful in cases like this when you have 3 OPC servers and an OPC client, and it has to go over a firewall or just deal with Windows PCs in different domains or work groups. So it can also be helpful in the reverse situation when you have 1 OPC server but a number of clients. As we said earlier, this also protects the OPC server from more than 1 OPC connection or undesired changes in polling rates in the hardware. So aggregation tunneling to MES/ERP systems might involve OPC aggregation to consolidate factory floor data. You've got OPC tunneling to get the data past firewalls, and OPC to web browser. OPC to Excel or ODBC, or even custom programs using the Data Hub's APIs to put the data where it can best be used by the MES or ERP system. And in this slide here, we have aggregating from an OPC server in a Linux box on the other side of a firewall and putting the data into an ODBC database and an Excel connection that reads the historic data from the database for charting. And here we have aggregation tunneling can really expand your integration possibilities. So this slide shows the top server InTouch client driver reading from InTouch. Data Hub then tunnels this over a corporate network through firewalls. And you can do the same type of thing with HMIs like GE, or you can do this kind of thing with RSView by reading them as OPC servers. So now that we've seen what aggregation and tunneling are, why you would use them, how it's done, let's talk about the tools you might need. So say we used a product called Cogent Data Hub. An important thing to know about all the aggregation and tunneling scenarios we talked about is there aren't really artificial limits to how many things like servers and clients that you can connect to a single data hub and how many tags you can configure in Data Hub. In OPC interoperability testing, Cogent Data Hub configurations have been made with tens of thousands of tags. You may need licenses on the remote machines where Data Hub also resides, but all in all, we just try to keep things simple. So let's go ahead and talk about some of the simple scenarios we covered. If one of the more advanced applications looks like something you may want to do, let me or Win know. We'll be happy to discuss some specifics with you. Just for the basic scenario of aggregating multiple OPC servers on a single computer, all you'll need is a single copy of Data Hub. When you add tunneling, in the case where OPC servers are on a PC and the OPC client is on another PC, you just simply have to add the second OPC Data Hub license. So that's all there is to it, and I'll go ahead and put up our contact information. We can open the floor for some questions.